Nice. So hello all, and thank you for joining us today, and thank the organizers for organizing such an amazing event. I had fun and learned some stuff during the day, and I'm pretty sure that you did as well, and that you will continue during the day. My name is Strahinja. I know it's a bit tough pronounced, but no worries, and I come from Serbia. I'm working as a program manager here in Microsoft Development Center in Serbia in the Azure Data team, and specifically on the serverless Synapse SQL pool. Today we're going to cover serverless as a feature inside Azure Synapse Analytics, and we'll see some introduction and overview of the service itself. So here are my LinkedIn and email in case you want to get in touch for any reason, and I guess we can start. So for today, agenda I prepared is first to get a brief overview of what serverless SQL pool is and how it works. And then we're gonna see what are the problems serverless SQL pool solves, some scenarios and practical demos. And after that, I'll show you two common usage patterns you noticed among our users while using serverless. And in the end, I'll leave a couple of more moments for you folks to ask questions, and I'll try my best to answer all of these. Okay, so I guess we can start. So serverless Synapse SQL pool is an interactive query service that enables you to use standard T-SQL queries over files in Azure storage, and it goes beyond that. So it is built-in inside the Azure Synapse Analytics. So it actually provides you a plug-and-play experience, because as soon as your Synapse workspace gets created, you're able to execute queries on serverless SQL endpoint just like that. Besides that, it uses T-SQL language. It also supports any tool or basically any programming language that uses T-SQL to query the data. Beyond that, we have a feature that automatically synchronizes Spark pool tables into serverless SQL pool. Actually, they're syncing table definitions. So if you create a Spark pool table, you will be getting a chance to utilize that through the SQL and query that data through serverless SQL endpoint. And most recently, we have announced Delta Lake public review. So you can actually query multiple storages through the serverless pool, like Azure Storage, Delta Lake, and Cosmos DB through the Synapse link. So why it's even called serverless? Well, it is called because there is no infrastructure, there is no upfront cost, no resource reservation, and as I said, it's plug-and-play experience. There is a pay-per-use model, which means that you're paying only for query execution per data processed. Later, I will get back to that, charging a bit more. And there is auto-scaling that provides most efficient resource allocation to get your data as quick as possible. And we are also providing a full schema on read and automatic schema inference for a variety types of file formats that you can use for running queries on serverless SQL endpoint are something like Azure Data Studio and SSMS. And the native IDE for Synapse is Synapse Studio, as I guess you're already previously familiar with. And basically, you can use any other tool that can actually run the SQL queries over the SQL serverless endpoint, like Power BI, Excel, Azure Analytics services, or pretty much any other programming language. So yeah, that's a nice overview of clients and tools. And how does that all work? So we have a distributed query execution flow, and here is this green thing is our user, and he's interacting with the SQL frontend. And SQL frontend is a place where, let's say, there are some metadata handling, security handling, and some query simplification done right there on the SQL frontend level, so like a filter push down, like a partition elimination, and similar. And after that, that gets propagated to the DQP. And the DQP is distributed query processor. And it's a part of the system that explores viable distributed execution plans and picks one with the lowest estimated cost and the most efficient way, of course. And it breaks that SQL user query into multiple T-SQL fragments, chunks, tasks, however you would like to call them. And then where they get propagated, it gets propagated to the SQL backend. So these backends are fully stateless. They're executing these tasks, and as soon as they get results back, they're propagating results back to the parent to merge them and show them to the user. Let's get to the recommended scenarios. So the first one is the ad hoc data exploration, and that is the let's say the first common scenario that a user faces when he starts using serverless. And basically, it is the way when you want to answer some questions like what is in this file, how are columns named, how many rows are there, and what's the max value, and similar. So you basically want to just understand what is the data you're working on, what's behind there, and how you can actually use that. So let me just head now to the Synapse workspace. I hope you folks can see that still. And here in the Synapse Studio, I can go, for instance, to the data here, and you can choose in the gallery. So in some data, you can browse in gallery. And here you have already predefined data sets that come in Synapse workspace, publicly available, of course. So for instance, let me choose this European Center for Disease Prevention and Control, ECDC. And here you can see the preview of the data, some description, data sets, volume, etc. Some basic information. And after I add data set, it will get added here in my Azure Blob Storage in sample data sets. I mean, this is already linked because I did that previously, but it will work for you as well. And if I click here on actions and create a new SQL script and run this, you will see that in a matter of seconds or moments, couple of moments, this query is getting executed. And utilizing an open overset function feature, it gets like through this Azure Data Lake, Pandemic Data Lake, publicly available storage, and it queries this ECDC cases per K file. We are putting here a file format, and it gets back as a result. So here you can see some preview of what data is and what's inside of it. So this is one, let's say, pretty common use case for exploration. And we can also, for instance, say here where countries and territories is equal to Serbia, for instance, or by month, and that, yeah. And so basically we can do some filtering here, and we here have the chart view in the results section of the Synapse Studio. And in the chart section, you can actually choose what are the data you want to expose here and to visualize data in the best way possible, so you can see visually what's going on over there. This is only for the first 6 months since I put here. It remained here. So basically, that's some visualization, and you can choose here, for instance, area or some other different chart type, so you can present it visually in a better way. That's some ad hoc data exploration, like a basic scenario. And now I would like to show you our second scenario, which is data transformation scenario. So let's imagine that we have some file or data set or whatever that we want to actually transform and to utilize the most of it in some way. And for instance, I have my data set in CSV in the example I'm going to show you, and the data is not optimized. So I, for instance, want to convert it into the Parquet file format. So how can I actually transform that? I can do that through the serverless, of course. And if I don't need some data, I can remove it, etc. So let me head back to the Synapse Studio. And here in Synapse Studio, I'll get back to Data Hub. And here in my primary Azure Data Lake storage, I can here upload some files, basically via this upload, and do some stuff I need. So I have already previously created this bestsellers.csv file, and I can just run select 100 just to show you that it works regularly. And since I here have my data in CSV, I want to convert that into Parquet for some reason. I mean, it usually happens for data optimization, or for example, you can have this data stored on some other storage account and you want to migrate it to another one, and similar. So these are the common use cases of data transformation. And here I have already the prepared scripts to not waste time on typing. I mean, I won't just copy paste a bunch of code like usually people in tutorials do, but I have some already prepared script. So I first created a database here called testDB with some collation that I like, and I here used it testDB for my serverless SQL endpoint. So I will first create a schema called my schema for the better file organization, just to show you that we can do that. And here I'm specifying the external file format called my.k with defined format type .k. You can also here define your data compression in case you have some compressed files like snappy.k or anything else. So this external file format we're using, we're creating here, we will actually later on use when we want to create that data and extract that to our storage. So this is not defining the data we are querying. It is defining the file type of the data we are going to store on our ADLS account. So I'm creating my file format, and here I can create my external data source. So it is a data source. So this my destination is a data source. This is the file path where I want this data to be exported. So if I head back to my file system, you can see that I have previously created my transformed data folder. And when I enter, you can see that it is completely empty. So when I get back to my script, and after I execute this query, he will know that this is the system will know that this is the file path where we want to store our created external table that we will run in a couple of next seconds or moments. So this feature is called status. So creating external table as select. So what is actually going on here? Let me just, okay, nice. So we here have this create external table, first called mySchema.myExternalTable. So inside this schema, we are creating external table called myExternalTable, with specifying the proper file format, data source, and location where this data is going to be extracted and stored. So as we already said, my.k is my file format, my destination is my destination, this file system transform data, and location, these new bestsellers, is a place where our data that we're going to query through the external tables will be stored. So after this create external table with clause, we have this as, and there comes this here comes the fun part. So it's a select query, and this query actually this is the main part where we are actually transforming the data we want to export with on the storage place we previously mentioned above. So we are here having some columns from that CSV file I ran previously. The columns inside the CSV are called from C1 to C7 because I didn't include the header row true, but you can exchange it in case your CSV has a header row, of course. So what I'm doing here, I'm casting the C1 column as a varchar 255 and setting that as a book name. So column number 1 will be named book name, column number 2 author, rating, price, publishing year, and genre. And I'm here defining my my types of the data that is going to be stored to use it most efficient way, let's say. And if you don't specify that, everything will be default column type will be varchar 8000. So after selecting the columns we want to export to our external table, we can also after that it comes the from open rows part where we are actually specifying the file we want to query and to transform, actually format of it and the parser version. So we're using parser version 2.0 because it has some new features, and let's see, it's better, it's faster and more optimized, but it lacks some of the features, but it's nothing major. So we are actually selecting the file which we want to query. We chose the columns, and here we are doing some filtering, which we want only to be stored. So we are transforming the data, and I also here intentionally left one column, so because I didn't want the column number 4. And after I run this query here, in a couple of seconds, my data, you literally see queries in 1 second. So this external table is created and defined in my test.db. And if I go back to my data hub and into this workspace place, in test.db, I need to refresh my external tables. And here I can see my schema dot my external table with columns I specified previously. So this is my external table, but please bear in mind the data that we are going to query via this external table is not stored here. So the data is stored on our file system on this path we previously provided. So if you go to the file system and come back to this file system transform data, you can see here that there is a new folder called new bestsellers with some parquet here named. And I can also query that from here. So that's the data I actually created and exported. And it would be, let's say, pretty much the same if I would do if I would query that from my schema, my external table, because my external table is pointing to that storage over there with providing the column. So I here have all of my data that I have transformed successfully. And that is the part of this data transformation, which is utilized by CTOS, and you can use that to transform some data, move it to some other storage accounts, and similar use cases. All right, so let me head back to my PowerPoint presentation, and I guess we can go to the third common scenario. So third common scenario is a moment when a user wants to query different sources. So for instance, we have some external data sources we want to access. And how can we do that actually? I mean, we can do that through serverless, of course. And how to join that data that is produced by various apps, IoT events, logs, and similar, and how to analyze this data through the same tool. Well, the solution for this is our scenario called Logical Data Warehouse, or LDW. So Logical Data Warehouse is a scenario where you can use your Synapse SQL to join the data from multiple storage accounts on multiple data sources and create a logical place where you will store these external tables and these schemas and actually query that data that is stored on these other external data sources. So how does this look in the practice? I'll come back to my Synapse Studio. Just give me a second. It's a bit tough when you speak only to your audience and there's no one in front of you actually, but new experience. So here I'll go back to my develop hub, and in the LDW folder I have created already a couple of scripts. So I will here use a hack once again to not copy paste the data, but copy paste the script, but just to have it already pre-written for me. I'm creating a database called the retail store, again with the collation I would like. And I will just make sure that I'm using retail store and not my old database from the previous examples. So what am I doing here is that I am actually creating an external data source called data with location this SQL Cosmos DB West. So this is some other data lake storage account that is not part of my Synapse workspace. And over there, I am also wanting to target this data part of this ADLS. So after I create this data source, I will create this external file format. And here, I know that my data stored on this ADLS account is in Parquet file format, and that is compressed by static codec. So I will also create an external file format, and I will also create my schema that I want. I mean, that I want to organize, since we will have two different external data sources. One will be this ADLS, and another one will be our Cosmos DB. So after I created the schema, I'm not sure if I showed you previously, but when I create this schema here, you can see schemas in this folder here. So we can see ADLS created already. So after we created the schema, it's time to create these external tables, like some dimensions that we are going to use for our logical data warehouse solution. I have here predefined three different dimensions. So one is called the product, another one is retail sales, and third is store demographics. So each one of these dimensions are describing a different part of the retail store system. So in the product, we have ID, product code name, product ID, and the wholesale cost. So these are the columns specified with their types. And here in with clause, we have again that data source. So we are targeting the data on our ADLS account, specifically in this product folder in the data part, and we are specifying here the file format. So after I create this, after I create this external table, and again refresh these external tables, here it will be showed. So I'll just run the same thing for retail sales, where we have some quantity and price, ID and store ID, and some other columns that we don't need to go through, I guess, because it's just for demonstrating purposes. And after that, we have some store demographics about income, minorities, high income 150 ratio, and other common demographics. Description, let's say. So we have created these three tables, and they are here called as ADLS product, ADLS retail sales, and ADLS.store demographics. So right now I can execute this select top 100 from ADLS store demographics, where store ID is equal to 9. And this will be executed on this ADLS account and read from this specific data / store demographics file path. And here you can see that we have that query. The results come back to us in couple of seconds. So we have already set up our ADLS logical data warehouse part and our dimensions for our retail store use case scenario. And now we want to combine this data from ADLS storage with data from Cosmos DB storage. So I here have created a Cosmos DB logical data warehouse part of the script. I have previously created my Cosmos DB Synapse account with my SaaS identity, shared access signature, and secret key. So after that, I will create a new schema called Cosmos DB, so we can distinguish the data that is external tables that are stored in Cosmos DB and in ADLS. And there's the same data stored on Cosmos DB storage account. So again, we have store demographics, retail sales, and products. And here we are creating views. So views is a logical way to just create the let's say connection to the storage on the Cosmos DB. And here we're specifying Cosmos DB and the concrete account we have previously created our credentials for. We are targeting the database that we want to get the data from and providing a key access to that part. So after I run this query, just to select the whole one, of course, I will get a created view on my database here with targeting the data stored on Cosmos DB storage. So here in data, I can go to the retail views and retail store and views, and here it is with Cosmos DB store demographics. and pretty much similar to external tables. Here are the columns defined for that specific view. And I can do the same thing for retail sales. Again, with the retail sales demo DB, again, same the account and key, and also the last one, but not the least one, are products. So after we created these three views, we are able to execute queries from each of these views through the serverless SQL endpoint. There are some differences between external tables and views. For instance, external tables are getting synced between Apache Spark pools and serverless Synapse SQL. Views can use open row sets. There are some minority differences, and perhaps in terms of performance inside of views, but you will see it through the usage of your serverless experience in time. And you can also check some links. I will leave you this whole presentation afterwards, so organizers can share with you. And I guess there will be a recording on the YouTube, of course, of this toboggan event, so you will be able to go through all of these examples I have created for you, and to see some resources that I will leave you in the end.
Thank you.
So, yeah, thank you. So here we're actually executing a query from Cosmos DB with some data that is stored over there. And we have now created our views and our external tables from these two different data sources. We are now finally able to merge them into one and to actually create some data warehousing reports. So here in develop, I have created the reports LDW script, and we will again use the retail store. And here is actually the most beautiful thing of the logical data warehouse. You can actually combine these two external tables and views, different external tables and views from different storage accounts or different data sources to utilize that and make one unique or unified report with these data combined. So as we can see here from the script, we are targeting the product name based on the product code from the Cosmos DB product table, actually view, sorry. And we are summing here total sales by quantity and price, summing that. And we are querying that from retail sales from ADLS storage account. So we are targeting the external table from ADLS and joining that with views from Cosmos DB on products based on that product code. And based on that product code, we are receiving the product name here. And we are targeting, we want to see what is the total sales based on the product where the store ID is 80, for the store number 80, or its ID is 80. And we're grouping that by product code and ordering that by total sales descending. And we can see that Surface Laptop 3 has the biggest sales, Surface Pro 7 a bit less, and Surface Go the least. And we can again utilize that as a chart here in our Synapse Studio. And this sector report is pretty much the same thing, just did on a different way. I mean, the report has the pretty similar effect and utilizing Cosmos DB and ADLS in the similar way. So we are joining data from ADLS and Cosmos DB so we can get the unified results. And here in the table, we can see the product name and total sales based on this query with this high income 150 ratio bigger than 0.9. So that's our LDW scenario. And here are the slides I mentioned previously. So basically, everything that I did in practice here in Synapse Studio are also here in slides. So let's revise what we covered here regarding the recommended usage scenarios. There are 3 recommended usage scenarios. And the first one is ad hoc data exploration. So ad hoc data exploration is a way where you can easily explore schema in data files on your Azure storage. It supports various file formats like Parquet, CSV, JSON. You can also use Synapse Link to query Cosmos DB. You can query also Delta Lake that is now in public preview. And this scenario for ADHOC exploration serves as a direct connector to Azure storage for large BI ecosystems, and to find what your data actually is. And after this first recommended scenario, there is a second one called Easy Data Transformation. So in Easy Data Transformation, as you previously saw, you can transform your CSV, for instance, to Parquet file format, but you can go beyond that and move some data between containers and accounts in case you need that on your ADLS accounts. And you can save the results of queries you're executing on external storages, like with the external tables or views. So you can utilize that later as already predefined some scenario or whatever you need. And third, our use case, common use case scenario is a logical data warehouse, where serverless SQL endpoint serves as a place where you can create like model raw files as a virtual tables and views, and you can also use any tool that works with SQL to analyze these files and organize that in the way that is most efficient for you, and from which you will receive the best reports for. And you can also use enterprise-grade security model that Azure Synapse is providing you. And you can also do some security models for some users, some similar things that you can actually organize through serverless. So all of these recommended scenarios you can see from Knowledge Center. I mean, I'm revising these for the folks that are maybe not too much familiar with the Synapse and serverless. So basically, in Azure Synapse Studio here, you can navigate. It's bugging a bit for a second. Okay, so you here have the Knowledge Center, and you can see some types of samples that you can use immediately, browse in gallery, and of course have some tour of Synapse. And for example, I know use samples immediately. You can query data with SQL, create external table with SQL, and for instance, I can use here my built-in pool, which built-in stands for serverless. Since it's a built-in pool when you create a Synapse workspace, then you can choose a database and similar, and you can literally start using these samples out of scratch. I mean, you will get some scripts generated, and you can understand what's going on here and how does it work and where's the data stored and similar. And there are also examples for external tables, creating external tables and similar. So I'm really encouraging all of you who are interested in diving into the Synapse and serverless to explore this Knowledge Center and learn more. Okay, so after we are done with these serverless recommended common scenarios, let's talk about usage patterns. So while we were talking with our users, we noticed a couple of usage patterns that are repeating all over again. And I will here represent two of these. So the first usage pattern that is really common is running a BI directly over the data lake. So right here on this graph, you can see that here we have Synapse pipelines, and Synapse pipelines serve for us to get some data get some files or some data from some on-premise server or whatever, and we can write that data into our Azure Data Lake storage. So we are literally ingesting data via Synapse pipelines. And when the data is ingested here, we can read that data through Synapse SQL. So serverless is used here to explore the data that is stored in Azure Data Lake storage, to create some views over files and similar. And we can do all of that through, for instance, Azure Data Studio or SSMS or any other client and tool you are familiar with and comfortable with this ad hoc querying and setting it up. And after that, you can use these views you have created to use them from Power BI for some reports and analytics and showing that to others, for teammates, reports, and similar. So this is a pretty common usage pattern this whole let's say pipeline, but this whole cycles is a way how you can utilize serverless via Synapse on the, let's say, most efficient way. So this is one of the common patterns, and the second common usage pattern is to enrich data in Spark and serve it with SQL. So here you'll notice pretty much similar graph, and we are here also again first ingesting data through Synapse pipelines. And from Azure Data Lake Storage, you can use Apache Spark for Azure Synapse to enrich that data by, for instance, Azure ML. And when you enrich the data using Spark, transform it or do some big heavy stuff on it, you can, thankfully to the automatic sync between Spark and serverless SQL, that these tables are getting synced, but only the data definitions, so you can actually utilize that from serverless. And from serverless, you can query that data and later also do again some ad hoc queries, create some views, store that data through the Power BI, and similar other, or do any other pretty much recommended scenario we spoke previously about. So that would be about our usage patterns. And I guess the one thing that probably some of you folks are asking is how do we charge? So how do we charge since this is a serverless model? So since this is a serverless model and serverless experience, we're charging this per data processed. So it starts from, I think, $5 per terabyte of data processed per region, but it depends on the region. It's not the same in the USA, UK, Europe, and similar. There might be a slight difference. So what does this mean? So we are charging per query, and the charging is rounded up to the closest megabyte, and the minimum is 10 megabytes. So when you start your Azure Synapse experience and you want to use serverless, we're not charging you for any server, or there are no upfront costs. But the moment when you execute the query, you will get charged, and only for the data that is being processed. And let me just emphasize that metadata only queries are not being charged here, like DDL and similar. So basically, only for that data that you need to receive as a result that you wanted through your query. And that to explain a bit more what data processed is. So data processed is amount of data temporarily stored in the system while executing a query, which means that there is an amount of data that is read from storage. So for instance, if you have a storage with you want to create a data set with hundreds of partitions of 100 gigabytes, and you have you want to create to query only one partition, you will get charged for that 1 gigabyte plus statistics that we created for you, or that you have created manually to utilize it even better. And we're also charging a bit for these intermediate results that are happening in the meantime. So if you have a couple of joins and similar things, you can actually you can actually get charged for that, but it's pretty small amounts usually, not always. And that's about these two parts. And please bear in mind that charges for other services are not included here. So like storage, like network cost that you're using, that is not something that is getting charged by us. So we are charging you only for the serverless SQL queries. And you can see that here from Monitor Hub in Synapse Studio. You can see some SQL requests here, and you can see that almost pretty much any of mine query is less than 10 megabytes. So here you can see, what's the script that you queried and similar. So you can actually understand which query cost you how much and who also submitted that, and similar stuff. So you can see here, create external table that it is charged, but only with this CTAS functionality. So not only the create external table, because it's only defining stuff in your database. So that's about the charging part, and you can pretty much everything that I spoke of today. You can check on these resources. It's usually some documentation that Microsoft provides. And Synapse link for Cosmos DB. You can see here how to plan your costs and manage your costs. Data warehouse example. This is a Git example with the full data, full scripts on, and similar stuff. So to summarize everything today, we have covered the serverless Synapse SQL. We did some overview of the features and functionalities, how you can use it, how you're getting charged, how does it work via this DQP distribution query processing system, and how you can, let's say, utilize it in the way you need it. You saw the recommended scenarios, which are extracting ad hoc, extracting data, ad hoc data exploration, and logical data warehouse. It's pretty recommended, and it's really common thing that our users do. And you also have seen the usage patterns that are most common for our users, like these Power BI reports and enriched with Spark and served with SQL. So that's it from my side, folks. And I think that we're like, this is like 40 minutes straight. Thank you so much, time. Thank you so much for your attention and for giving me the opportunity to represent to you. I'm now open for questions if there are any.